Welcome back. Today's story is called The Earth Inside Out, Part 2. Our learning targets are to identify the difference between things that are solid, liquid, and gas, describe the mantle and the core of the Earth, demonstrate an understanding of the word solid, identify and differentiate between the layers of the Earth, and color code and label the 3 layers of the Earth. Our key vocabulary are erupts, liquid, molten, solid, and volcano. Erupts is a verb, and it means to send out lava, ash, and gas in a sudden explosion. Okay? When a volcano erupts, it is a sudden explosion that sends out lava, ash, and gas. Liquid. Okay, we've talked about liquids before, liquids, solids, and gases before. Liquids do not keep its shape. They don't keep their shape, and instead they take the shape of the container. Okay, so if you look in this picture, this seems to be kind of in like a rectangular jar or glass, right? But if you poured it into a round glass, it would look like it was round, right? Molten. Molten means melted, okay? It takes very high temperatures to melt metals into molten forms. So there's melted metal. Solid. Solid is something that keeps its shape, okay? My glasses case, solid. My pen, solid, okay? All solids. Volcano. A volcano is a mountain that forms over a crack in the Earth's crust, from which lava, ash, gas, and fire erupts. In order to study the volcano, the scientists had to climb from the bottom of the volcano to the very top. The land on the surface of the crust is continents, and the water is called oceans. Where is the North Pole, the South Pole, and the equator? Hang on, I'm getting my globe. So, where is my North Pole? Top or bottom? Top. There's my North Pole. Where's my South Pole? Bottom. And where's my equator? Around the center. Remember that the equator is an imaginary line that splits our globe into a northern hemisphere and a southern hemisphere. Okay. Who remembers what the layers of the Earth are? What are the layers of the Earth? We've got the one that we live on, which is the crust. We have this next one, which is the mantle. And then these 2 parts make up the core. We have the outer core and the inner core. Oopsie, went too far. All right. So the crust is where geologists look to learn about the history of the Earth. The many layers of rock found in the crust can teach us about different periods of time in Earth's history. I want you to show me the 3 important words. Say them and show me the hand signals we have for them. Heat, pressure, time. All right, you do it on your own. Ready? Go ahead. Heat, pressure, time. Okay. Why are these important when we study geology? Because they do what to the Earth? They change the Earth, right? They cause changes to the Earth. So things on Earth can be described as solid, liquid, or gas. Remember, solids are going to keep their shape. Liquid can be poured. It doesn't keep shape, but it will take shape of containers. Gas. Gas is often hard to see. It's not solid because it doesn't keep shape, and it's not liquid because it can't be poured. Okay. So an ice cube is the solid form of water. Water is the liquid form of water. Water vapor or steam is the gas form of water. Remember our key vocabulary, we have erupts, liquid, molten, solid, and volcano. Inside the earth are solids and liquids. Listen carefully to find out more from Jerry the geologist about the layers of the earth, the mantle, and the core. Today, we are going to pretend that we can journey deep, deep into the earth, all the way to the very center, nearly 4,000 miles from where you are sitting right now. The first stop is the layer beneath the crust, which is called the mantle, right here, okay? The mantle is a whopping 1,800 miles thick and contains most of the Earth's rock. Okay. Because most of the Earth is made of rock, that means that most of the Earth is contained within the mantle. So the mantle is the biggest part of our Earth. That's the biggest layer, the thickest layer. And that's where most of the rock is. The mantle is mostly made of solid rock. The closer to the crust, the cooler and harder the mantle tends to be. But as you go deeper and closer to the core, the mantle gets hotter and becomes soft and gooey. Heat closer to the core causes the rock inside the mantle to move around quite a bit. But in most places, it is still solid rather than liquid. Did you hear the word heat again? Heat causes parts of the mantle to move around. Remember, something that is solid keeps its shape, while something that is liquid can move around and take the shape of whatever it is in. The mantle surrounds the core, or the center of the earth. So remember, this was our mantle, that's most of the earth, and then inside of the mantle is the core. The inner core, so this yellow part, is a solid metal ball. The outer core is also metal, but it is not solid. It is made up of melted or molten metal. If metal is molten, that means that the heat has changed it from solid to liquid. This means that deep down inside the earth, thousands of miles beneath your feet, there is a giant sea of red hot, molten metal surrounding a solid metal ball. So what does it mean if the inner core is solid? Can it change shape? No. Can it be poured? No. Scientists believe that the very center of the Earth, the inner core, is actually hotter than the surface of the sun. What? The sun is about 10,000 degrees Fahrenheit. A really hot day in the United States is about 100 degrees Fahrenheit. So 10,000 degrees Fahrenheit is extremely hot. The inner core is much hotter than the outer core. It may seem strange, therefore, that the outer core on the Earth is molten metal, yet the inner core at the very center of the Earth, where it is the hottest, is a solid ball of metal, which, by the way, it's just a bit smaller than the moon. So that was a lot of information right there. So I'm going to explain a little bit of it. So remember, this orange and yellow part all together make up the core, right? But it's saying that the very center, so just the yellow part, which happens to be the size of our moon, is solid, but it's hotter than the outer core, which is kind of weird if you think about it, because if it's hotter, you would expect it to be melted, right? So let's find out why it's not melted. The reason that the inner core is solid has to do with the incredible pressure of the Earth's entire weight pressing inward. The more pressure you put on something, the more heat you need to cause that thing to boil or melt. This is why the metal at the very center of the Earth, the inner core, is solid instead of liquid. Despite the intense heat, there is simply too much pressure caused by the weight of the rest of the Earth, so the center of the Earth cannot melt and it remains solid. Did you hear that word pressure? Remember that pressure causes the inner core to be solid rather than liquid. The crust upon which we live is constantly being changed and reshaped due to the heat and pressure caused by an activity in the Earth's mantle or core. Did you hear those words, heat and pressure? Heat and pressure in the Earth's mantle change the crust. So the heat and pressure that's in this layer of the Earth is causing things on the top layer, or the crust, which is where we live, to change. Okay. The San Bernardino Mountains that you see in this picture, along with many other mountains along the west coast of North America from Mexico to Alaska, were created by changes inside the Earth. So the reason that we have those mountains are because of changes that happened in the mantle. Remember, the parts of the mantle that are closest to the core are soft and gooey. That hot, gooey material in the mantle does not always stay in the mantle. Sometimes it rises up to the surface. Every so often, some of that extremely hot molten rock or magma pushes up through the mantle and forces its way through the cracks and crevices in the crust. Over time, the magma collects in a magma chamber, such as the one near the bottom of this picture. So this right here is the magma chamber. The heat in the magma chamber releases gas from the magma, which builds up and creates pressure. The pressure builds and builds until one day, boom, the magma erupts in a volcano of lava, ash, gas, and fire. Once it is released from the earth, the magma becomes lava, flowing liquid rock, which flows across the ground until it cools and hardens into a solid rock once again. Okay. What do you see in this picture? A volcano. Now that I've told you about volcanoes, let me explain one more thing. Thanks to geologists, we have a pretty good idea when and where these geologic events are likely to occur. Geologists help predict where volcanoes are most likely to occur, and this helps keep people safe by discouraging them from building homes close to dangerous areas. It is not always possible to predict when and where geologic disasters will occur, but geologists work hard to give people as much warning as we can. Okay. All right, if you need a break, hop up, take a break, and then come back for our questions and word work. All right, so what are the names of the layers of the earth? Let's go from the outside in. So the outside layer is called the crust, and then we have the mantle, and then we have two parts of the core. We have the outer core and then the inner core. Okay. What's the mantle like? That's where most of Earth's rock is, right? It gets hotter and softer the closer you get to the core. So let me go back to that picture. So we've got our mantle, right? And it's made mostly of rock, okay? And the closer you get to the core, so the closer you get to the orange, the hotter it gets, okay? The hotter and softer it gets. Describe the outer core. Tell me about this part, the outer core. Is it solid or is it liquid? It's liquid, remember? It's molten metal. How about the inner core, the yellow part? It's a solid metal ball. And why is the inner core solid rather than liquid when the inner core is hotter than the outer core? The inner core is solid rather than liquid because there is too much pressure from all of the weight of the rest of the earth to allow the inner core to melt. Okay. Let's go back to, actually, we'll leave it there for now. So what causes a volcano to form? How does that happen? Magma from inside the earth makes its way to the surface of the earth and causes a volcano to form. Okay, so the magma is that hot, gooey stuff that comes and it pushes through the cracks of the crust of the earth, and that's how we get volcanoes. Why is it important for us to study volcanoes? To keep people safe, right? If we know about volcanoes and we know when and where they're going to happen, we can keep people from putting their homes there so that they don't get hurt when the volcano erupts, right? All right, let's go back and we can do our word work. All righty. In the read aloud you heard, heat closer to the core causes the rocks inside the mantle to move around quite a bit. But in most places, it is still solid rather than liquid. Say the word solid with me. Solid. Can you say it in a whisper voice? Solid. Can you say it in a robot voice? Solid. All right. If something is solid, it keeps its shape. It was so cold outside last night that the water puddle became solid ice. I'm going to name an object. If it is something that is solid, say, that is solid. If it is not something that is solid, say, that is not solid. A book. That is solid. Milk. That's not solid. Water. That is not solid. That's a liquid. A desk. That is solid. A shoe. That's solid. Steam coming out of a hot bowl of soup. That's not solid. That's a gas. Okay. All right. Let's see. Let's make sure we have hit our learning targets. All right. Did we identify the difference between things that are solid, liquid, and gas? Yeah. Did we describe the mantle and the core of the earth? Did we practice with the word solid? Were we able to identify and tell the differences between the layers of the earth? Did you color code and label the layers of the earth? No, but you're going to do it in just a moment, okay? There's one more video that you need to watch, and then you can do your color coding and you'll be done. Have a great day.